We've seen the theoretical background to the demand curve last week, but what about the supply curve when we're thinking about a perfectly competitive market where we've got the demand-supply cross? To know that, we need to know about costs of production. So this week we focus on the topic of costs. Next week we'll use this information to derive a supply curve for a perfectly competitive market. But the theory of production, and here we're using an orthodox or neoclassical theory of production, it's not just useful for deriving a supply curve in a perfectly competitive market. The theory is used to analyse the behaviour of all firms, whether they exist in competitive markets or not. So, much later, we're going to look at non-competitive markets and imperfectly competitive markets. And we'll use this same theory of costs to understand the firms in those markets too. To start with, you might think that when we look at costs and we calculate costs here, we're doing something like basic accounting. But in economics, we are concerned with something more interesting than that. Something that is generally not examined in accounting. So what's that? We're interested in a certain special set of patterns that the costs of production of a firm will exhibit as it increases output. We can see this pattern especially if we use graphs of a firm's costs. So we'll look at those in the next few videos. When we're thinking in terms of the neoclassical theory of the firm, the short run means a situation in which the firm can't change the quantity of at least one of the inputs used in the production process. In other words, at least one input is fixed in quantity. Usually there will also be at least one input which is variable. That is, it can be changed in the short run. Of course, it's conceivable, strictly speaking, that you could have a situation where a firm can't alter the quantity of any of its inputs. In that case, we'd be talking about the very short run or a market period. But we're not going to worry about that particular situation. Now, as to which input is fixed in the short run depends on the industry you're looking at. In different industries, different kinds of inputs might be fixed. The traditional example that you would find in textbooks very often, or used to, is manufacturing. In the short run, usually the factory and the machinery in the factory, the capital, and the space that's used, the land, is fixed, whereas the number of workers employed or the period of time which the workers are employed can be varied. You can increase it or decrease it. And similarly, you can change the quantity of the raw materials used. They can be increased or decreased, depending on whether the firm wants to increase production or decrease production. The firm can hire workers and fire workers very quickly. It can order more or less raw material very quickly. But it can't gain access to new land or build a new factory instantly. This takes time. So in the short run, we would traditionally say that these two inputs, land or space, and capital, tools, machinery, and so on, are normally fixed. The long run, by contrast, is a situation in which the firm is able to change the quantities of all of its inputs used in the production process. In other words, all of the inputs are going to be variable. In the long run, a firm can build as many new factories as it wants, and it can populate them with workers and raw material. So, in the long run, a firm can change the scale of its operations. But this is not possible in the short run. A useful mantra to use is this: a firm produces in the short run, but it plans production in the long run. So here's a neat table to try and explain what's this distinction between short run and long run. So in the short run, we're going to have fixed inputs and variable inputs. Inputs which can't be changed, and inputs which can be changed. They can be increased in order to produce more output. We would say that fixed inputs are very often capital and space, or land. The size of the factory, for example, in the short run can't be changed. Or if it's a cafe, the size of the cafe itself, its dimensions can't be changed, and the number of machines that are in the cafe can't be changed for that reason. On the other hand, we would normally classify raw materials and labour as variable inputs. You can increase the number of raw materials used and increase the amount of labour employed in order to increase production or output. In the case of the long run, there are no fixed inputs, so all the inputs are variable. They can all be changed. So this obviously includes all the different categories that we would normally think of as being inputs into the production process. The law can be stated as follows in very general terms. After some output point, some level of output, each additional unit of a variable input that's used in the production process will contribute less to total output than the previous unit of that type of input. If we then tried to make it a little bit more concrete and assumed that labour is the variable input that we're interested in here, we would say that after some output point, each new worker produces less than the previous worker employed. And this is progressively the case. So the third worker contributes 10 widgets, and the fourth worker contributes 9, and the fifth worker contributes 8, and the sixth worker contributes 7, and so on. This is our law of diminishing marginal returns. The returns here being the output of the variable input which is utilised. If we look at this table here, we've got the number of hours worked, standing for labour, and we've got the amount of wheat produced in tonnes. So we can see as more hours are added, more wheat can be produced. All other things are remaining equal. So the amount of machinery utilised, for example, is remaining constant. The land is remaining constant. And if we look here at the marginal product, or what we've called the marginal return, the additional tonnes produced by 1,000 additional hours of labour. Here we would take the original quantity, it's increased by 250 units. So that's that increase in output of 250 units is due to an additional 1,000 hours of labour. So we can see that the marginal return, or the marginal product, is falling with each additional 1,000 hours of labour added. So this is representing our law of diminishing marginal returns to labour in this case. If we were to graph this, we want to graph the total output on one axis and the total number of hours worked on another axis. We'd get this curve here. It's called a production function. So as we increase the number of hours worked by thousands, we get increases in output. And we can see, by virtue of the changing slope of this production function, that while it's increasing at a decreasing rate. It goes up by smaller and smaller increments of output. So each additional 1,000 hours of work causes total production to go up by smaller and smaller amounts. In fact, we can see here the last increment of labour, the last 1,000 hours worked, contributes nothing to total output. Total output remains the same. Alright, that's that.